in R. Now let us go to straightaway EDA analysis. I am opening EDA analysis and trying to show how to open already existing file in R. So this file, wherever I have worked this file, I need to save it. So you can save the file by clicking on the file and say save as we know that, and you can put name of your own choice of the file. Let us talk about, this is the today underscore objects which we have done and we used in FDP. I will share this file with you, that is why I am trying to do it. So this is FDP day 2. So you can understand what has been done in the day 2. I am putting into desktop, so you can find it into desktop. So this way your file nomenclature has been done. So you will find this is the nomenclature appeared. Earlier it was just like untitled file. So it was not saved, so it is called as untitled file, number so and so, because these many files are already open in my R program. Now let us go to the basic exploratory analysis. Let me open the file and then I will talk about what is exploratory analysis, why exploratory analysis is desired and required to start our analysis. Those who are into research, they need the starting point of analysis. So look at the look at the moment I have called up the file. Look at the situation. This is the first quadrant where file has been retrieved and these 4 items are there. I am into tutorial, so nothing is visible in the tutorial. I am into connections, you will find connections if need be. I am into history, you can see whatever I have done it is reflected into the history here. So whatever the code you have run, you can find into history and you can copy these codes here. So these are the things loaded 212, more than 212 entries I have done. So this is being in the history. Now this is the environment. What is global environment? So you can open this global environment, you will find various packages here. So you can pick and choose any package and load the package. All these packages are already loaded here. You remain into the history, you can use this, and this is what is a console here. Right now I have opened the console in a full view, so you can easily see what is happening in the console. Here are terminals, and right now terminals are not functioning. You can reduce the size and make it again 4 quadrant. So whenever you have to attach some files, whenever you have to attach some, okay, these kind of issue comes, you need to give the access to our sessions. These are the protocols, and these protocols you need to follow. So you can update the details, you will find here files, you can, whatever you are bringing in the system of R, these files are uploaded. So look at the files here, you will find your files hanging around. So you can delete these files, you can add the files, you can bring by putting the name, you can bring the files into folders. So you can create folders within the R atmosphere also. You can attach packages from here. I will tell you how to do it. You can use the help format here, you can use the viewer format here, so you can have the details about that. For example, right now I'm trying to show you a inbuilt exercise of data called Iris data. Iris data is an inbuilt data set which I am using it to demonstrate what is exploratory data analysis. Exploratory data analysis, as everybody must be knowing about it, that we are trying we are trying to identify these outliers and try to remove these outliers which are existing in the data. Once you are able to identify these outliers, you try to remove these outliers and then go to the setting of data again, and ultimately you can start doing the analysis. If you will do the data analysis with the already given raw data, what will happen? Your analysis report will not be up to that level. And what is going to it going to reflect in your analysis? Your analysis will not be fine-tuned, your prediction will not be fine-tuned. Ultimately, what has happened, that what you are trying to do with the analysis. So why this is required, this I have already talked about. I will go into the details also. What I am going to talk about here, the role of EDA role, I am going to explain it in the slide also using different aspect. I have not prepared any slide, but I will make it live why and how this EDA can be used in this whole process. This is basically talking about EDA detailing. So this is the slide which we need to refer, called data analytics. Under the data analytics, for example, you have to create analysis which is basically referring to different types. So there are various types of analysis we try to list upon, or we try to see how these analysis functions, how these analysis works. So these analyses are of great use. So here you have say you are trying to explore. So this is called exploration or exploratory analysis. And here it should not come, it should be go into details of here. So you try to explore the data, and you try to find out how the exploratory data analysis functions. So I think I should pick up this. Yes, so you are trying to explore the data. So this is exploratory data analysis we are trying to do, and we functions around the exploratory data. This is the first part of this, and it will help us to do the prediction. You are trying to do the data, and you are trying to see the data in the form of predictive analysis. You are just going to see the data into predictive analysis based upon exploratory data analysis. And ultimately, once you are trying to explore the data, you understand the trends, and once you understand what kind of a data you have, then you look for prediction part. Prediction part can be done based upon your aspect of what you are trying to guesstimate based upon the current data you have. It may be 1 year, 2 year, 3 year, or it may be quarterly data or 5-year data. So you are trying to make prediction. So next level, once you are trying to do the prediction, you are trying to see the aspect that how exploratory data is going to be of use. So what is your trend, what your data is describing? So you try to see the descriptive data analysis. So this is what is the descriptive data analysis, where your data has been describing the various aspects. For example, you have launched some product, or you have launched a services of logistics in the market, and you are trying to see how this service is going to function. So that is the exploratory part. Once you know that this logistics service which you have performed or achieved are doing really fantastic, you are trying to describe what you have done good in the market in order to run the service at the optimal level of situation, where customers are preferring trying to prefer your services offered by your company. So that is the descriptive part. Now you want to see that after 10 years, or after 7 years, or after 5 years, or after 3 years, in the short run and long run, how your company is going to grow. So that is based upon the prediction analysis, or this is called predictive analysis is concerned. Then you have, after prediction, once you have explored the data, once you have described the data, once you have done the prescription, now you get into the prescribed, not prediction, prescribed. So this is called prescriptive data analysis. Here you are trying to prescribe the aspect that this is going to be the future. This is going to be, if you do this, it will be going to shape your work. If you are going to bring the practices in, it is going to bring your services in time. What you will do, you bring, say, a few months where the lean season is there. You are prescribing, yeah, you should come up with some promotional aspect. You should allow, say, you can charge, say, 95% of the item being shipped for using your logistics instead of 100%. So this 5% breather in this scheme in the lean season is called prescriptive analysis. So there are four types of analysis. One is exploratory analysis, another one is descriptive analysis, third one is prescriptive analysis, and last one is prescribing. You are trying to prescribe, that is prescribe, you are trying to do the prescriptive analysis. So this is also called prescriptive analysis. So this prescriptive analysis, this one is descriptive and another one is prescriptive analysis. Both are playing very important role in today's scenario. And now let's go back after stating what type of this is all types or kinds of analytics. So these are basic four types of analytics. Worldwide it has been used, and why we need to get into four types of analytics or analysis, that of because of our customers are becoming very dynamic. They are in touch with the social platform. Social platform or social media is very dynamic. It changes in minutes, in hours, in days, in months, in quarter, in by month, 6 months time period, in 12 months or year, and so changes are very dynamic. It is happening every minute. That is why we need to do these four different type of analytics in our business, and these analytics can be done very well using your R approach. So this is what is the foundation and theory behind doing the EDP. And EDP is basically focused on, you are trying to explore. This is the stage one of a researcher when they are trying to use that. Now once it is being done, what is the exploratory data analysis? What is why we need to do this kind of analysis or exploratory analytics? That you need to understand what kind of a data you have and what you are going to do with that data. So this is the basic aspect of our exploratory data analysis. And if you will not try to do the data analytics in the exploratory stage, you will not able to reach to the description portion. You will not able to describe your analytics. So descriptive analytics will not take place. You will not able to reach to the predictive analytics if you have not explored your data very well, or if you have explored the data in a wrong fashion. What will happen? The descriptive stage will be also wrongly reached. Similarly, the prescription is also going to be based upon your analytics of exploration will also not able to achieve the optimal results. So whatever the schemes you make based upon your prediction will go haywire. And same thing, you are trying to prescribe as a consultant. As a data scientist, as a consultant, if you're prescribing your institution, your home, your corporate or your own firm, your prescription may not be going to be workable 100%. So this is one of the major challenge that you need to face, and you need to deal with that. Whenever you are predicting, whenever you are exploring, your exploration should be the best. So this was basically the basic aspect behind this exploratory data analytics. So until unless you explore the data, you will not come up with the results. Now let's go and see this data technique, how it functions. So I have used a case study called Irish dataset. This is the inbuilt dataset, and this inbuilt dataset has got what is stored in this inbuilt dataset. I'm trying to show you first that. So here is I'm using the help to demonstrate what
Kindly,
is this.
sir, share the screen first.
Okay. The moment I shift, I have to share it again, I suppose. Is this shared?
Yes, it's shared.
Okay, done. But I have shared full screen today also. No problem, that's okay. Now visible? Okay, so now I am repeating one or two sentences because I think that was not visible. So I am going to carry forward the exploratory data analysis, which is basically we are trying to using the inbuilt data set in the system. That inbuilt data set in the R system we are talking about, that is R atmosphere. This is called iris data set. So what is iris data set? Let me show you by your, you can see better, and if you, I will show you, you can retain better. So instead of speaking, let me show you what is there in the iris data set. What you will do, just at the bottom of this is the on your right hand side of your screen, and on the bottom quadrant you go to help, and once you will go to help, type here in the search and put the name of the query you have. So my query is what is Irish data set. So I am writing here. So what is Irish data set? So this is going to bring that Irish data set qualities. Let me check whether it is possibly bring or not. Okay, I will copy it here. Earlier something else has been searched, so it is showing that. So put it here, you will get your results. Okay, let me rephrase it. So sometime keywords don't work and sometime it takes some time. So let me check why this function has not performing our results. Let me rephrase the thing. So if you see, some changes has been done. So iris dataset. So this is what is the details of the dataset. So here you will find changes because I have changed the keyword. So the moment I have changed the keyword, the resultant is in front of you. Now I am increasing the size so you can see it better. So this iris dataset is in front of you. What is iris dataset? Let us go through that. So this iris datasets are of two types. One describing this is a fabulous features or endures iris dataset, gives the measurement in the centimeters of variables of sepal length, and width, petal length of flower, and respectively for 50 flowers from each of three different species of Irish flower, and species are Irish setosa, vesicula, and vernica. So these different species are being put it into test. So two data sets are there. There are Irish data set of Irish flowers or Irish data set 3 of Irish flowers. Right now I am putting the data analytics on Irish data set. So what is the format? What is there in the data set? So here you can see Irish data set is a data frame with 150 cases, means rows, 5 variables which are named as sepal.length, sepal.width, petal.length, petal.width, and species. Iris 3 gives same data arrangements and 3 different dimensions with 50 by 3 by 4 by 3 as represented by S plus, and we will have this idea what is this data set, and based upon this data set it was given by Fisher RA in 1936, and still it is one of the best tool to be yet used during the multiple measurement taxonomy problem annals, and these are the basic bioset we have been used to do it. This dataset was collected by Anderson in 1935, which is in this, and particularly the publication happened like this. So this is the example of data set, and you can see the example also and use this example for your own learning. Now let's, once you are able to understand what kind of a data set is there, what is there in the data set, let's go straight away to the data analysis. So first command I'm using here is referring to data Irish. So this is what I am trying to call the data. So you are calling the data by this person, this command. So data Irish is being called. So let me wipe out this whole board. So by this broom, you can wipe out the previous run code, and what you will do, you can have the fresh screen in front of you. So I'm increasing and putting into two code system of screen, so it will be more visible. Let me run this and show it to you in front of you. So I'm calling the data called arrays. So I use the code data bracket start bracket close Irish, and data is being added into this. Then I'm talking about what is there, what all names are there in Irish. I'm calling the Irish names. So Irish has got a variables which are 5 in numbers, which has been shown by this. So what is there in the Irish in terms of names of variables? So sepal.length, sepal.width, petal.length, petal.width, and species or species. So now let's go into the technical part of it. So this is what is a whole portion. Now let's summarize this data. What is the summary? So this is the descriptive analysis we are referring to. In this descriptive analysis, as we have promised it, the data set is clearly visible, and you will see the 5 item wise the summary of the data. So I will take the 5th one called species. So species means number of elements picked up, 3 varieties of flowers, Setosa, Varicula, and Vernica. 50 items of each flower has been picked into data exploratory data analysis using this data set. So here is the sepal.length. Sepal.length whose minima is 4.300. The first quartile is 5.100, medium is 5.800, median is 5.843, third quartile is 6.400, maxima is, this is the height which in centimeters. As you know that in the system it is all the measurements are in centimeters. So maxima is 7. So minimum height of this particular species length is 4.30, first quartile is 5, and medium is 5.8, and mean is 5.83. So very close to the medium is the average. Now let's go into the sepal width. So sepal width is little bit smaller, almost half the size of it. Minima is 2.00, first quartile is 2.800, medium is 3.00, and mean is 3.057, which is higher than the median is concerned. You will find always mean is, or there might be a change. So they are very close to each other, but they remains up and down only. So very close. Median is to be checked properly with the mean average. So minima is 2.00, first quartile 2.80, median is 3.00, mean is or average is 3.057, and third quartile 3.300, maxima is 4.400. Petal length, which is another variant, minima is, which is also smaller, half of it almost. This is 1.00. First quartile is 1.60. Median is 4.340, and mean is 3.570. Third quartile is 5.100. Maxima is 6.9. Similarly, when you go to the petal width is still smaller. So this is what is the whole gamut of understanding of summary of data. So this is what is we need to understand the summarization of data. You can see the structure if you put here str and just type the name of database. Let's see what it comes for you. So this is the structure of the data. It will show this is the complete structure of the data in front of you. So before summary, you once the data set comes to your name, it is my advice, use this particular command immediately before summary. So then it makes more sense. So what is there is this data set called iris data set has got 150 observations of 5 variables. Here the sepal dot length has got these many observations, and then species has got 3 species as it is already shown. So this is the whole structure of the data as I have shown you inside the data aspects. So once these basic analytics has been done, let's go on to the graphical part. So let's presume examine the data distribution, which is one of the major part, and it will only pick up only the quantifiable variables. No descriptive variables will be picked up. So I will not go to the statistical part, but I will definitely touch upon the inferences aspects are concerned. So this is the histogram has been created. So you will find at the bottom the histogram has come up. So this is the histogram which I have used the code, and to create this beautiful figure in front of you, you will find things. If you are touching upon the edges, it will show something called uniformity in the data. So this histogram brings the detailed aspect of the data set. So it is visible, it will be demonstrate whatever there in the data set is clearly evidented and explained using the so-called graphical analysis. So this is the one of the major benefit and beauty of our so-called analysis is concerned. Now let's go on to finding the as we have planned to understand the outliers in the system. So how the outliers in the system can be brought in forward to see what all outliers are there. So outliers are here. So it can be identified in the basic statistics when we study stats. So outlier identification should be done by using box plot. So box plot code is written here. First of all, let me explain the code of histogram. So here we call it hist bracket start irish $sign sepal dot length this is showing the distribution of one variable. It can be shown for others also. Let me take one by one. So it will be much easier. You can do the hands-on based upon this data set. You can retrieve the data. If you want, it will be really interesting exercise to be created by all participants simultaneously. Also, I can wait for their whole exercise. Let me perform few tests. Then I will ask you and guide you. If you want, simultaneously things can happen. So let us go to the box plot. The box plot command is bracket start iris dollar sepal dot length and main summary of iris has been picked. Here x is sepal length. So let me create this. Let me check whether the command has done. Yes, so command has done. We got the data summary of iris. So this is the box plot. So these are called whiskers. Here is the medium, first quartile and third quartile here, and you will find anything is not outside the whiskers. So if dots comes here, so what will happen? It is called as outliers. Let me take you, copy the image and take you to the slide and make you little bit, those who are very new to the research, they can understand from this activity. So anything falls into this, I'm just picking up and also demonstrating how the resultant can be picked it into your work. So I think I should this is the paste special. I have used it to show it. For example, Let me do it full screen to use annotations. Can I use annotations? Yes. From here, I'm using one annotation. For example, if certain points are falling into after whisker, or here some these are called the outliers. These are the outliers where it is going beyond the control. So this is the main issue which we should see to it. So that is why I'm trying to make you understand that these things are one of the critical things. If dots come to here and dot comes to here, it leads to a lot of trouble for us. Until unless we remove these outliers, data will not fall into the shape. So this is one of the major aspect where we need to see through the detailing of whole process. Now is this screen available? Because I'm back.
Yes, available.
Great, thank you. Now let us go to the back and try to evolve this code for another thing. Let me say goodbye to annotations. Uh, Exiting or not? Yes. So let it be. Okay. Now let's see. Can this hist be prepared for other variables? Let us check. So I'm creating hist for the iris variable. You will find the default is coming. This is the biggest advantage of Studio when you use. This is the biggest example of Studio, that when you write code, it will show default. So you will get the indicator. Look at this indicator. So this is the hist. I'm trying to evolve the hist, and now I am trying to put the code. Data is iris, and we can select the iris database from here also. So here I'm using the dollar sign. Now look at the options available. So when you are writing, use these default codes so you may not able to commit mistakes of spellings. So you have done it for length. Now let me put for sepal width. So once it is done, I will try to run this. So will we, oh, this is purely fantastic figure we have achieved. This is called histogram of iris sepal width, which is purely in the bell shape, and more uniformed data set is there. Okay. So this is what is the current aspect of the data set. Now let me create its box plot. Now let's go here and type the code. This is called box, and this is called default code comes. So do not try to type everything. Machine will give you the options and make use of intelligence of the machine. So this is what I am trying to use it called box plot. And now what I have to do and create the box plot of iris, take a default. I always take a default, and then width I have used here. Now let me prepare the graph. So you will find something here. So what I suggested you, look at this. These are called outliers. These are called outliers. Until unless you remove these outliers, the data will not be optimally uh, analyzed. So in this case, maybe we are not able to rectify the outliers here because it is inbuilt data set. We can have the alternative strategies in this case. So you will find certain outliers, though the histogram is clearly saying that this is what is clearly bell-shaped kind of a curve, normally distributed data, but in the normal distribution also there might be a chance few data points are beyond situation, beyond averages. So this is quite possible. Let us do a creation for histogram. So here let us do a histogram. Default code must come. So this is hist. So this is the default code. Never use your unnecessarily application of things, use the default. So here Irish Now what is left? So options are there. So we have created length, we have created width. Let's go to the petal width. So once you will go to the petal width, create the diagram of Hist. So you will find data is abnormally, it's not uniform. It is having a lot of gaps. So this is not uniform. This is non-uniform data. Now let us check whether uh, box plot, what kind of a image comes with the box plot here. So this is the box and this is the plot we are picking up. Irish data set. Yes, so we picked up this default code and use the dollar sign and we are creating a petal. So now let's assume this petal length. So you will find this petal length. You can write this code partially. You can write the code with the full details also. So here petal length is there, and you can mark a comma, then main main is equal to code starts summary summary of Irish. So this is not caps. Iris. It is also in the code. Yes. Let's assume that it should call XAV is equal to length is talking about here. Yes. So we are talking about petal thing. So here TAL PE, there is capital PETAL petal dot length. So length comes. So here is the code. So same thing you will find. Don't worry about it. So only thing is that the details are very well shown on the top. If you want to keep it Y, let us see whether it is going to come with the Y or not. Let us plot this. So anything change? Anything has been changed here? Nothing has been much change. So changes are in the detailing. If you find this change is visible here, it is shifted to the Y portion. Earlier it was on the X portion. So look at this X portion implication. So I picked up this. Just remember this. Okay, just remember this. So here the Y axis coming. Now I am replacing instead of Y, it is X. So it will reflect on the X axis. Just see, it has been reflected in the X axis. This is what is written. The diagram won't change, only the parameters visibility change. So just see and try to make a lot of experiments using all these things. So this is the first level of analysis we are able to see through and do the whole part of it. I am going in a right fashion to make you understand how two different basic diagrams functions in the process. Now let's see to the second stage of exploratory data science. Here what you are doing, you are trying to plot two different features of flower. So here we are trying to see the relationship of a plot between the two quantitative variables. So here Irish sepal dot length and sepal dot width are being plotted. So you will find this data. So this is a scatter plot has been done. So on the x-axis you will find the length, on the y-axis you will find the width. So look at the situation. If you change the so-called axis, we can change the axis also. So we'll go to the plot. We will write first iris, and we are picking up iris, then dollar. Here we are trying to pick up not length, we are trying to pick up width, comma, again pick up iris, then pick up dollar, then length is written here. So just remember this, focus this. I'm just, for your convenience, I'm just trying to copy it for your convenience and taking you to the slide. So it will make a comparison. Can you see my slide? And I'm in the flip mode. Can
Yes.
you see the slide? or I need to share it again?
No, no, already visible.
Okay, visible. So this is the first diagram which I have prepared with the state of where so image has been performed. So you will find here, once this, I will make a comparison and then I will explain what I did in front of you right now. So here is the existing diagram where width is picked up. Let us do it here. So here you will see the width is picked up in the first go. Let me check first. Let me remove this, otherwise it is going to create a conflict for us. And let me clear this whole diagram. Yes, I'm clearing this diagram. So there will be no conflict in front of us. We are going to go back to the existing code. What is happening? Let's see. We are comparing and seeing the relationship between quantitative variables too. So these two quantitative variables are basically length and width. So first diagram I have created it using this, where the length is shown on the x-axis, and on the y-axis its width is shown. So this we will copy it, take it to the slide. So we'll remove this and keep our confusion, no confusion, scope for no confusion. Yes. So here I wrote this and use this as the basic aspect. Now let me change the verticals. Do you think vertical change will create any impact on the diagram? So here I'm writing the code again and put the width in front, comma, iris dollar length. So width is on y-axis. Yes, so definitely it has created an impact, though it looks very simple, but until unless you realize your own self, you don't believe on your resource words. So doing and seeing is called believing. So that is why the moment you have changed the pattern, the graph pattern also changes. The moment you have changed the plans, things will definitely change. If you can see, we put length first, it is on x-axis. We put width first, it is on x-axis. So replacement has been changed and scenario of the diagram has been also changed. Now it is the turn for the analysis. So what our diagrams are saying? These diagrams are called as, let me go to the original one. So this diagram is called scatter plot. Now I am increasing the details. Here is the width, here is the length. Can you see any phasing it out? Any analysis? Can you do this? Any analysis can you find out? Only thing is that there is no trend can be estimated using this kind of analysis. So its points are scattered on planes x and y, but no trend is found. It is scattering here and there, no line straight, no curvilinear trend, no exponential, no constant trend has been set. So let us see how beautifully we can get into the analysis with different aspects. So these are the things which we need to see into the whole process, and these are the basic aspects where you can modify whole scenarios and try to bring the details into the portion. Let me check the other parts of the analysis where we have dealt it in more detail, this kind of a thing. Let me check. Yes. So let me go to the another set. Let it be this here, and I will see to it where I have another file stored for you for the analysis. X and Y. Yes. So this is the same sheet with more details. We have plotted up to this and see the details and relations and